In lesson 97, we're going to learn about similar triangles, and then we'll apply what we've learned to a study of indirect measure. Now, we define similar triangles as triangles which have angles that are of equal measure. They don't have to be the same size, it's just that their angles are the same measure. For example, this angle here on the triangle on the left is the same measure as this angle here, and we can represent that by one tick mark. And then this top angle, which we could represent and distinguish from the other one by using two tick marks, is the same as that angle there. And then that third angle, we haven't identified it at all, but if two angles are the same in similar triangles, then the third ones are the same as well. Remember, the sum of the angles in a triangle is 180 degrees. So, for example, if two angles were measured at 45 degrees, the other one would have to be 90. And so if you had two similar triangles that had angles, or a pair of angles that were not 45 degrees in each one, that third angle in each one would have to be 90 degrees. So when you know two of the angles, then you also know the third one. Now, maybe you recall talking about the fact that the bigger the angle, or the bigger the vertex in a triangle, the longer the side opposite that vertex is going to be. In similar triangles, we call those sides opposite similar angles, we call those corresponding sides. For example, let's do the side opposite the one tick marked angle. We'll just put one tick mark through that side. And we'll do that over on the right as well. Those are corresponding sides. And then the sides opposite two tick marks, we'll put two tick marks on those sides. Those corresponding sides are proportional to each other. So I bet you can figure out what we can do when we have similar triangles. We could figure out a missing side. If this side was 12 and this side was 8, this side was 3, and we didn't know that side, we could set up a proportion. We know that corresponding sides are proportional to each other, so we could say 12 over 3 is equal to 8 over x. Cross multiply, 12x equals 24, so x equals 2. Remember that about similar triangles. Corresponding sides are proportional to each other. Let's do a couple of practice problems. I want you to solve for x and y, and you could recognize right there that you have similar triangles because you have two angles that have one tick mark, two angles that have two tick marks. That's representing equal angles. So that means those third angles that don't have tick marks, those have to be equal as well. If you know two of the angles are equal, then the third ones have to be equal also. To solve for x, we can set up a proportion because we know that the sides opposite equal angles, those are called corresponding sides, and we know those are proportional to each other. Usually the way I always set up these proportions is I put the left triangle's value on top and then the right triangle's value on bottom. So if we're solving for x, we need to do x over 2, and then we'll have to do 24 over 4. We don't want to do 30 over y because then we would have two unknown values in the same equation. We can't solve it. If we can only have one unknown value per equation if we want to solve it. So we'll have to do 24 over 4, which we could reduce to 6 over 1. And then we end up with x equals 12, right, if we did the cross multiplication. And so there's our answer. X is 12. For y, a similar process. We need to do 30 over y as our proportion is equal to 24 over 4 again, which we already know is 6 over 1. And that will give us 6y equals 30, or y equals 5. Similar triangles are not necessarily the same size. They do have equal angles though. And the sides opposite equal angles, we call those corresponding sides. Those corresponding sides are proportional to each other. Look at practice problem C. This is an application of what you've learned about similar triangles, and you just have to recognize and maybe visualize similar triangles to solve this problem. It says that a tree casts a shadow 35 feet long, while a 7-foot pole casts a shadow 14 feet long. How tall is the tree? Well, this is a similar triangle problem. In the book, they have some examples on how to do these problems, and they set up a ratio table. I think it's more descriptive just to draw a picture. And let's just think about the sun. If the sun was shining and sending out its rays in a direction like that, we might have this tree here, and then we might have a pole over here. The tree would cast a shadow this whole distance here, 35 feet. While the pole right here, which is 7 feet tall, would just cast a shadow from here to the ground over there, which would be 14 feet long. Now my drawing here isn't exactly to scale, but hopefully you get the idea here. Can you see that you would have two similar triangles? Here's one of them coming up through the tree and back down, and then here is the light pole, and we can assume that these occurrences or these shadows are being cast at the exact same time of day. That's what they're talking about here. They're not saying one of them was at noon and the other one was at 3 p.m. or something. Then this angle on the corner here, that would be different. Look at this another way. Let's take that bigger triangle, just redraw it like that, and then look at the smaller triangle. I'll put that one above. It has one side of 14, one side of 7. The big one has one side of 35, and then this side, H, we don't know. That's what we're trying to figure out, is the height of that tree. So we can just set up a proportion. H over 7 equals 35 over 14. We can factor out a 7 there and end up with 5 over 2. And so we can do cross multiplication. 2h equals 35. And h would equal 17.5. Or we could just say 17.5 feet. So on problems like this, you'll be doing some more of those. You just have to understand that the sun is shining at the same angle downward for both different cases that they give you. That allows you to set up similar triangles. And also we can assume that, like if we're talking about a tree and a pole, that those are perpendicular to the ground, so we can put a right angle box on the corners of those triangles. Then we know they have two angles that are the same. That means the third angle is also the same. So when you see a shadow problem again, just remember similar triangles. Those are proportional to each other. Make yourself a drawing like this. If you want to do the ratio box method, you can go back and do that if you want to. I think it's better just to make yourself some drawings like this to help you visualize your similar triangles. And I think that's better because that's how you learn about similar triangles, is you're looking at the different triangles and observing their similar angles and their corresponding sides and everything. So to solve a problem where you need similar triangles, I think it's the best way to do it is just to draw yourself some similar triangles. Okay, well that's all for lesson 97.